Hello chemistry students, this is Mr. Benner and we're going to go over chemical reactions, at least the introduction to them and why you would need to balance them. So chemical reaction is a process in which one substance or more than one substance changes into another substance or substances. The example given here is you start off with some iodine crystals and some zinc powder, and then after performing a little bit of heating on them, they react and they produce zinc iodide. So you started with two chemicals and you ended up with a different chemical, at least in terms of the properties the substance would have, but it does still have the same types of atoms present, just rearranged in a different way. So we've made a new substance. All right, so a few ways you can tell that a chemical reaction has taken place. You might see a surprising color change, and when I say surprising, I mean a color change that's not predicted by either, like when you mix colors of paint in art, like, if you mix yellow and blue, you get green. That's not a surprising color change. Or if you water down some Gatorade and it's a lighter color than it was to start with, that's not a surprising change either. The surprising changes are like you mix two clear liquids and you get like a yellow solid or something. By the way, that yellow solid would be an example of a precipitate forming if you mix liquids together and you get a solid that forms. Okay, heat being produced by reaction or absorbed. So if heat is released by reaction, the reaction mixture gets warmer. If it's absorbed, the reaction mixture gets colder. So those are evidences of chemical change, and also gases being produced. And you would see typically bubbles forming if a gas is being produced. All right, chemical equations are going to be a way that we write out a chemical reaction on paper to represent what's happening in the reaction. We're going to show the reactants on the left side of the reaction, the products on the right side, and then the relative amounts by showing these coefficients. And later we're going to talk about why you need to balance a reaction using coefficients. So the numbers in front in green are the coefficients. Just like in math, that's a multiplier that tells you how many of the thing that follows. So this says 4 aluminums, 3 O2s, which would be 6 total oxygen atoms, and then that makes 2 aluminum oxides, and in this aluminum oxide there would be 2 aluminum atoms times the coefficient of 2 makes 4 aluminum atoms, and 3 oxygen atoms times 2 makes a total of 6 oxygen atoms. So you might notice that there's the same number of atoms of aluminum and oxygen in the reactant side and in the product side, and that's going to be important for balancing equations later. Okay, the letters S, G, and L are used to represent the physical states of the compounds as solid, gas, or liquid. Usually those aren't super important for understanding what's happening in the reaction, or particularly not important for balancing the reaction, but you may see those and wonder what they are, and that's what they're there for. Okay, so we're going to, when we write equations, sometimes we'll have to write the word equation, then we'll put in the chemical formulas in place of the word equation, and then we will balance the equation using coefficients. All right, so the reactants are on the left, the products are on the right. There's an arrow that separates those. The arrow is usually read as yields or produces, so this would read carbon plus oxygen. Remember, oxygen is one of the diatomic gases, makes or yields carbon dioxide. Okay, one example, charcoal used in a grill is mostly carbon. A reaction to describe that would be carbon plus oxygen, because you need oxygen for a combustion or a burning reaction to take place, yields carbon dioxide. Now, chemical reactions must be balanced because of the law of conservation of matter. And that was determined by Lavoisier way back in the day. And what he did was did reactions in a closed container and noticed that before and after all reactions taking place in a closed container that the mass was the same. So even though the atoms are being rearranged, the mass is staying constant. All right, here's some more symbols used in chemical equations. One we didn't see earlier with the states is aqueous. That means that a solid or a liquid is dissolved in water. Sometimes you'll see this listed as a catalyst being used, and sometimes these symbols are used. Particularly the most common one is putting the triangle in there, and that'll usually be over the reaction arrow, and that's just saying that there's heat added to cause the reaction to occur. All right, so when you balance equations, do not change the subscripts. Those are the little numbers down below the symbols. Change the coefficients. If you change the subscripts, what you're doing is you're changing the composition of a compound, and that is not what you want to do, because presumably once you write out the chemical formulas, you have the correct chemical formulas. So those don't need to change. You need to change the coefficients to change the amounts of those chemical formulas present, but don't change the chemical formula itself. Now, just to give you an idea of the difference between subscripts and coefficients, so these particle diagrams show you the atoms of the elements involved here. So C means one carbon atom. O means one oxygen atom. O2, like a diatomic molecule of oxygen, means one molecule with two oxygen atoms in it. CO, carbon monoxide, would be one carbon bonded to one oxygen. Bonded, they're drawn together, so they're touching each other. If they're not bonded to each other, then you would draw them separately of each other, like these down here. CO2, one carbon, two oxygens. We've drawn that molecule several times. Now, if you want to say that you have more than one carbon dioxide molecule, then this is what you would say. Coefficient means that you're adding more of the same molecule. Notice these molecules are not bonded together. Changing a subscript changes the number of things that are actually chemically bonded, or the number of atoms that are actually in the molecule chemically bonded to one another. All right, so how do we balance equations? We're going to balance them by changing coefficients. When an equation is balanced, the number of each type of atom involved in the chemical equation will be equal before and after the reaction, or in other words, the number of each type of atom present in the reactants will equal the number of each type of atom present in the products. Okay, so this reaction that we looked at earlier, the aluminum and the oxygen reacting to make aluminum oxide, that's another way you could say that, is that 4 aluminum atoms react with 3 oxygen molecules to make 2 molecules, or really formula units because this is an ionic compound, but 2 molecules of Al2O3. Later we're going to say that that also will do moles when we do stoichiometry. So there is a direct proportionality between atoms and moles and molecules and moles, so this proportion works for that as well. All right, so when you balance equations, one thing, always check, and this is a general guideline, always check for the presence of diatomic molecules. That's probably the number one error I see when students write chemical reactions, is that there are supposed to be diatomic molecules and they're not, or they make molecules diatomic that are not diatomic. Remember Brinkelhoff, BRIN, CL, and F are all supposed to be diatomic molecules. Okay. We're going to list all the elements and or polyatomic ions present in the center of the equation beneath the arrow. That's to keep track, and I'll show you that in a separate video. Balance the metals, balance the nonmetals, balance hydrogen, balance oxygen, recount everything, make sure it's still balanced. And if by chance you end up with every coefficient being able to reduce in other words, you have not reached the lowest whole number ratio, then you need to reduce and rewrite in the simplest or lowest whole number ratio. And again, change coefficients when you're balancing, never change subscripts unless you find that you have incorrectly written the formula for a compound. All right, so we'll look at a couple of these here and talk through how you would balance them. So without the coefficients here, this would say 2 hydrogen atoms plus 2 oxygen atoms make H2O, which has 2 hydrogen atoms and 1 oxygen. Well, where did the other oxygen go? So it would not be balanced. So we could put a coefficient of 2 here, and that would make there be 2 oxygen atoms present, but it would also make there be 4 hydrogen atoms present. 2 times 2 gives you 4. So you would come over here and add a 2 coefficient as well, and that would make it so that there are now 4 hydrogen atoms on the left side. So you could check yourself and see that there are 4 hydrogen atoms on the left and on the right of the arrow, and then 2 oxygen atoms on the left and the right of the atom. All right, here's another example of that. So the Al2Br6, and in balancing this one, nothing has to be changed on the right side of the equation, just on the left side. So 2 aluminums on this side, there was only 1, so we put a coefficient of 2 to multiply that, make there be 2 aluminum atoms on the left, and there were 6 bromine atoms on the right side, so we multiplied the Br2. By the way, that 2's there because bromine is one of the Brinkelhoffs, it's diatomic. So 3 times 2 gives you 6, so that's how we came up with a coefficient of 3 there. In a separate video, I'll do more practice with balancing equations.